All right. Welcome to the Chapter 8 Review Explained. As I've mentioned in class, Chapter 8 is really all about vocabulary. It's mainly focused on quadrilaterals and the 7 types of quadrilaterals that we've studied. It actually starts off with a little bit of general information about all polygons. So to find the sum of the measures of angles in a polygon, what you have to do is use this little formula here. N minus 2 times 180, where n is the number of sides. So a pentagon has 5 sides. Again, you got to know a little vocabulary. You have to know that a pentagon has 5 sides. So you do 5 minus 2 times 180. Now you can either type that in your calculator with the parentheses and all, or what I usually do is just do 5 minus 2 is 3, just mental math. And then I would type in 3 times 180, and I get 540 degrees. So that is our answer, 540 degrees. All right, a nonagon. You should know that a nonagon has 9 sides. So 9 minus 2 times 180, or that's really just 7 times 180. Enter that in your calculator, and you get 1,260 degrees. All right, a 15gon. We know that the polygons past 10 sides, they do have names, but we really only have to learn them up through 10. So we'll just call this a 15gon. So same thing, 15 minus 2 times 180, so that's really just 13 times 180. 2,340 degrees. All right, the next set of questions is saying the opposite. It's giving you the number of degrees inside a polygon. You have to figure out how many sides. So we're still going to use the same formula, n minus 2 times 180, but we don't know what the n is. That's the issue. That's what we need to find. But I know when you do n minus 2 times 180, you get 900 degrees. So you just set up a little equation like this, and then you solve it. Although you could, if you wanted, you could distribute the 180. It's a lot easier to just divide the 180 right away. So I always just divide by 180 right away with these problems. So we'll do 900 divided by 180, and you get 5. So n minus 2 equals 5. And then you'd have to add 2 to both sides. So n equals 7. So there are 7 sides, and that makes it a heptagon. Again, you should really know the names of the polygons from 3 sides to 10 sides. You can always go back and review from Chapter 1 what all those are. 3 sides we call it a triangle. 4 sides is a quadrilateral. 5 sides is a pentagon. 6 is a hexagon. 7, like this one, is a heptagon. 8 is an octagon. 9 is a nonagon. And 10 is a decagon. So you should know those ones by heart. All right, here's another one, same type of thing. So we'll just take this 3,240 degrees, and we'll set it equal to n minus 2 times 180. Make sure you have the parentheses on there, and make sure you divide by 180 first. So we're just going to divide each side by 180. That will cancel out on the right side. On the left side, when you type that in, you get 18. So 18 equals n minus 2. Make sure you don't stop there. The answer is not 18 sides. You have to add 2 to both sides, so there's going to be 20 sides to this. And there probably is a name for a 20-sided polygon, but we'll just call it a 20gon. If it's above 10, go ahead and just say the number dash gon. Okay, number 6, same type of thing. n minus 2 times 180, in this case it equals 1800. So what kind of shape has 1800 degrees inside? Well, we'll divide by 180. And so that's just going to equal 10. And then add 2. And so this is a 12-sided figure. You could call it a 12gon, or actually we did learn this one. This kind of has a funny name, a dodecagon. So that is one of the ones we learned way back in Chapter 1. All right, number 7 and 8. We're finding the value of x, and what's going on here is we have to figure out what kind of polygon this is. So I count 1, 2, 3, 4, 5, 6 sides. It's a hexagon. So how many degrees should be inside a hexagon? Well, you do n minus 2, or 6 minus 2, times 180. So that's just 4 times 180. So that would be 720 degrees. Then, on the other side of this equation, actually add up all of these angles here in this shape. So I'll start with the x and go x plus 124 plus 140 plus 142 plus 105 plus 88. All right, let me add all those up. All right, added those all up and got 599. So we'll subtract 599 from both sides. And x is already kind of by itself, so that's all we have to do is subtract it. And in this case, we get 121. So that is what x is equal to. All right, let's take a look at number 8. Number 8, same kind of deal. So first I'm going to figure out what kind of shape this is. It says 1, 2, 3, 4, 5. So a pentagon. So I'll do 5 minus 2 times 180, or that's really just 3 times 180. Actually, if you go back to number 1, we already figured out a pentagon has 540 degrees. And that should add up to all of these degrees inside. So I'll start with the 2x and the 3x, and then all the other sides, 110, 86, and 64. All right, so when I add the 2x and the 3x, I get 5x. And when you add the other three together, you get 260. So you're just solving this little equation now. Subtract 260 from both sides. 540 minus 260 is 280. And then we'll divide that by 5, since it's 5x. And so you should get 56. I'll go ahead and write that up here. X equals 56. So again, to summarize with the last two problems, what you're doing is you're first figuring out how many degrees there should be inside, just based on what kind of shape it is. Then you're actually adding up all of the degrees on the inside. So you set those two amounts equal, and you can solve from there. Now what we learned about one like number 9 and 10 is that these are called external angles. And you don't have to count the sides here. Any polygon, if you add up all of the external angles, any convex polygon, it should add up to 360. So I'm just going to go ahead and start off with 360 equals, and then we'll add all the others up. I'll do x plus 2x plus 75 plus 93. I find it helpful to add them up either going clockwise or counterclockwise, either one. So let's see here. We'll have 360 equals 3x, and then 75 plus 93 is 168. So then we'll subtract 168 from each side, and you get 192. And then divide by 3, and you get 64. So x has to equal 64 in this case. All right, number 10, same kind of thing. We're looking at external angles. Even though this one has 5 external angles and the last one only had 4, the external angles are going to add up to 360. So we know right away it's 360. I'll do x plus 4x plus, the 2x. So I like to keep the x's together. And then we'll also add the 90 and the 60. All right, so x and 4x and 2x makes 7x. 90 and 60 makes 150. If we subtract 150 from each side, we'll get 210. And then if we divide by 7, we'll get 30. So x has to be 30. All right, actually, those first 10 problems are all of lesson 8.1. That was kind of a big first lesson. And then, starting in 8.2, we started looking at parallelograms. And there are 5 things that we know about parallelograms. if you have a parallelogram. In 11 and 12, they tell us right away they are parallelograms. One is that the opposite sides are parallel. And they look parallel, and in this case certainly are. So those sides are parallel, those sides are parallel. The other first thing is that opposite sides are congruent. So x plus 2 and 4, those are congruent. You can set them equal, and so we'll get x equals 2. Same thing with the other sides. 12 and y minus 5, those will be the same. So add 5, and y is 17. So opposite sides are parallel. Opposite sides are also congruent. Those are the first two rules of parallelograms. The next rule about a parallelogram is that opposite angles are congruent. So this angle here and this angle here are going to be congruent. So I'll set those equal. Y minus 60 equals 56. You have to add 60 on both sides, and so you get 116 for y. And then you can use the other rule we learned, that opposite sides are congruent. So 16 equals 3x plus 4. So those are the first three rules about parallelograms. There's two of them I haven't mentioned yet. So here we get x equals 4 if we solve that. So I bet on the next page we will encounter the other two rules. Okay, so we're still dealing with parallelograms on this page. One of the other rules that we learned about parallelograms is that consecutive angles add up to 180. So like f plus 30 and 72, together they add up to 180 degrees. So I'll do f plus 30 plus 72 equals 180 degrees. Okay, so 30 plus 72 is 102, and then subtract 102 from both sides. So f equals 78. We can also use the other rule we talked about, that opposite sides of parallelograms are congruent. So 25 is going to equal 8g minus 3. So add 3 to both sides. I mean, really, you know how to solve these equations. It's the setting up part that is new. And then we would have to divide both sides by 8. So 28 divided by 8. I don't think it comes out evenly, but I type it in and I get 3.5. 3.5. Okay, and the only other rule about parallelograms that I haven't mentioned yet in this video is that any parallelogram, the diagonals of the parallelogram bisect each other. Now, that does not mean that these two diagonals are the same length. What it means is that each one's split in half. So this part and this part are congruent, and this part and this part are congruent. But it doesn't mean that all four of them are congruent. So, again, we can just set some of these equal to each other. I can do 9 equals 2n minus 1. I'll need to add 1 and add 1 to get 10. Divide by 2, and n equals 5. Likewise, with this other set, I can do m plus 8 equals 3m. I'm going to subtract m from each side. So I'll have 8 equals 2m, and then divide by 2, m equals 4. So the four rules of parallelograms are that opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles add up to 180, and the diagonals bisect each other. Okay, so let's talk about how this would relate to a graph. It says to graph 3 points of the parallelogram, so I'll go ahead and do that. A is at -8, 2. And when I put my point on the graph, I like to label that. That's A right there. B is at -6 and up 3. C, we don't know where C is, I guess. And D is at -3, 1. Okay, now, before you start looking where the other point is going to end up, let's connect some dots. This has to be connected in order A, B, C, D, because that's what it says. 3 of the vertices of parallelogram ABCD are given. So that's the order that the dots have to be connected in. So A is going to connect to B, B is going to connect to C, but I don't know where that is. C will connect to D, and lastly, D is going to connect back to A. So this is part of what the parallelogram is going to look like, and that might help you realize that the missing point is going to be somewhere over here. There's 2 ways that you can get that, and they both involve counting the slope. Zoom in a little bit here. From A to B, I can count that the slope is up 1 over 2. So it has a slope of positive 1/2. Now, since this is a parallelogram, opposite sides should be congruent and parallel. It has the same slope. So this side over here should also have a slope of up 1 over 2. And so if you do that, up 1 over 2, that would be this point right here. So that must be where the missing point is. And that is -1, positive 2. So that is the answer we're looking for. Go ahead and connect the dots and make sure it looks to be parallel. You know, the other thing we could have done is counted the other slope. From A to D, it looks like we're going down 1 over 1, 2, 3, 4, 5, so -1/5. And you can check to make sure that that's the other slope. Down 1 over 1, 2, 3, 4, 5. Yep, it works. Also, make sure that your letters are connecting in order. A, B, C, D, and back to A. All right, let's do another one like that. So look at 16. Okay, this time A is the missing one. That's all right. We don't care which one's missing as long as we can graph these. So B is at 4, -4. Make sure you count carefully. Remember, when you're graphing, it's the left or right that happens first, then the up or down. Okay, C is at 6, -9. So C is down here. D is at 1, -10. And we don't know where A is. So connect them in order. B is going to connect to C, C is going to connect to D, and then we don't know what A is. So I'll just find the slope. From D to C, I'm going up 1 over 1, 2, 3, 4, 5. Up 1 over 5. So the slope is 1/5. And I could do the same thing. I mean, I can see that the missing point A is somewhere in this area here. I mean, you can just tell because that's where it'd have to be a parallelogram. So the slope from D to C is positive 1/5. I may need to do that backwards for the opposite side. So I'm going to go down 1 and over to the left. 1, 2, 3, 4, 5. So the missing point should be right there. Go ahead, connect the dots, make sure it makes sense. So that should also have a slope of 1/5, up 1 over 5. And then if you do the other side from B to C, it looks like we're going down 1, 2, 3, 4, 5, and over 2. So that one has a slope of -5/2. Make sure that that follows. So down 1, 2, 3, 4, 5, over 2. Yep, this also has a slope of -5/2. So where is this point? Starting from 0, 0, we're going -1 and down 1, 2, 3, 4, 5. So point A is at -1, -5. We want the coordinates, so that's what they would be. All right, another one. A is at -3, -4. B is at -1, 2. So that's up here. C is at 7, 0. That's right here. And we don't know where D is. I'll go ahead and connect the dots. A to B, B to C. And so that probably tells you that D is going to be somewhere down here. If I count the slope from B to C, I'm going down 2 and over 8. So -2/8. 1/8. I know we usually simplify the slope, but this would be a case where we don't want to simplify it, because if you simplify it, you'll lose the true distance. So from there, the opposite side, the side that's right here, should be the same, use the same number. So I'm going to go down 2 and over 1, 2, 3, 4, 5, 6, 7, 8. So this should be the point. And so that should be point D. So go ahead and connect those dots. And where is that? That's at, how do I get there? From here I go over 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5, 6. So 5, negative 6. Make sure you can write the coordinates correctly. That's something you've got to be able to do. Okay. On to the next set. We dealt with rhombuses. A rhombus is a type of parallelogram, and the main thing that puts parallelograms aside is that all 4 sides are congruent in a rhombus. Another thing that we learned about rhombuses is that the diagonals of rhombuses cross perpendicularly. So those are going to cross at a perpendicular 90-degree angle. And the other thing we learned about parallelograms is that the diagonals bisect the angles that they touch. So like up here at Q, these 2 angles here will be the same, and actually they'll be the same as these ones by S. Same thing over here. These 2 angles by P will both be the same. Apparently they're both 30 degrees, right? Because the one on the bottom's 30 degrees, so this one's also 30. And that means these ones up here are also both going to be 30 degrees and 30 degrees. So those are the additional things we learned about parallelograms. Let's go ahead and answer the questions. Number 18, find the measure of QPR. QPR. So QPR, oh, we already figured out that's 30 degrees. I usually like to look at the diagram first and figure out a little bit of information about it and then answer the questions. Number 19, QTP. 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 All right, we talked about how the diagonals cross at a 90-degree right angle. So that measure is 90 degrees. All right, what's up next? Number 20, RP. From R to P. Okay, I know R to T is 6, and a rhombus is a type of parallelogram. So all of those rules that we learned about parallelograms that we talked about, they also apply to a rhombus. So the diagonals of a rhombus are bisected. They're each cut in half. So if that's 6, this should also be 6. And altogether, RP is 12. And lastly, QT. QT, all right, from Q to T. I don't know either QT or TS. How am I going to figure this out? Let's see here, did they give us any given information? Well, I already marked that all down. Well, you notice that all 4 of these sections are right triangles. They're all right triangles. So everything that we learned in the last 2 chapters from December, January, and February, we can apply here because those were all about right triangles. So we are looking for QT. So maybe I'll kind of separate that little triangle out. I know this is a 90-degree angle. This is 6. This is 30 degrees. And I want to know this. We can't use the Pythagorean theorem because we only know one side of the triangle and not 2. So we'll have to use like a sine or a cosine or a tangent. And when I look at this from 30 degrees point of view, x would be the opposite, 6 would be the adjacent. And so it's the tangent of 30 that would be opposite over adjacent. X over 6. Okay, to solve that, we'll multiply both sides by 6. And so I'll go ahead and type that in. 6 times tangent of 30, and I get 3.46 approximately. Doesn't really say what to round to, so I'll just round to 3.46, or I suppose you could say 3.5. Like I said, it doesn't really round, or it doesn't say what to round to. So QT equals 3.46. And as I was doing this problem, I was thinking, you know, there's actually a slightly different way to look at this problem. The triangle that we have is a 30, 60, 90 triangle. We have 30 degrees, this is 90, and so this would have to be 60. And so we learned back in semester 1 that this special kind of right triangle, 30, 60, 90, if you know what the shorter leg is, you multiply it by radical 3, to get the longer leg. Now we don't know what that is, so we'll have to do this in reverse. If you know the longer leg, you divide by radical 3 to get the shorter leg. So I could take that 6 and divide it by radical 3. And usually we would not leave our answer with a radical in the denominator, so you'd have to multiply both top and bottom by radical 3. And so you'd have 6 radical 3 over just 3. And the 6 divides by 3 to just make 2. So 2 radical 3. That would be the exact answer. The question didn't specify whether to give the exact or approximate answer, so either one is fine. You could either do 3.46 or you could do 2 radical 3. Okay. The next set of problems is all about a rectangle. Let's go over some of the things that we know about rectangle. First of all, the defining characteristic of a rectangle is that all 4 of its angles are right angles. They're all 90 degrees. And so in this case, because this part is 50 degrees, we can just do 90 minus 50 to figure out that this is 40 degrees. Okay. And they're also telling us that xz is 12. From x to z is 12. Now the other thing that we know about any parallelogram is that the diagonals bisect each other. So this part of the diagonal is equal to this part, and this part's equal to this part. But more specifically in a rectangle, the entire 2 diagonals are congruent. So what that means is when you split them into parts, actually all 4 of these small little diagonal halves will be congruent. So if xz is 12, that means that this is 6 and this is 6, and also this is 6 and this is 6 because it's a rectangle. All right, let's answer some of these questions. Number 22, what's the measure of WXZ? WXZ, that's 40 degrees. That was actually the very first one that we did. So let's go ahead and write that in. 40 degrees. Okay, what's up next? WPX. WPX. All right, so that's WPX. That's this angle right here. What might be helpful is to draw that triangle, WPX. I'm just going to draw it outside the shape. Sometimes it's easier to see what you're dealing with when you take it outside the shape. Now this is 40 degrees right here, and this side is 6 and this side is 6. That means these two sides are the same, and this is a isosceles triangle. That means this angle will also be 40. So if I want to get the remaining angle, I can just do 180 minus 40 minus 40. And if you type that in, 180 minus 40, you get 100 degrees. So this angle is 100 degrees. If you want to fill that in on your diagram, you can. This is 100. This one would also be 100. Since this is a straight line, these are a linear pair. They need to add up to 180, so actually this would be 80, and this would be 82 because they're vertical. It might look like these are perpendicular, but they're not. This is not a rhombus. This is a rectangle. Okay, what's up next? PY. How are we going to come up with PY? Oh, we already figured that out, and that was 6. All right, and the last one, WX. WX, that's this top portion here. I know in a rectangle that opposite sides are congruent, but I don't know what this other side is. So I can think of two ways to figure this out. If you want to use the original triangle that we were looking at here to figure out wx, we could do that. The issue here is that this is not a right triangle. So you can't use the Pythagorean theorem or a sine or a cosine or tangent or one of those, at least not directly. If you remember from last unit, what you can use to solve a non-right triangle is either the law of sines or the law of cosines. So I could set this up. Let's say I use this angle side pair, and I say sine of 40 over 6, and then I will compare that with these. Sine of 100 over, I don't know, x, or I'll call it wx, because that's this distance from w to x. Okay, so cross multiplying, on one side I'll have wx times sine of 40. On the other side, we'll have 6 times sine of 100. And then we'll have to divide by sine of 40, because we want to know what wx is, so we want to get it by itself. And so you can just type that into your calculator. Just make sure you close the parentheses. So 6 times sine of 100 divided by sine of 40. And we'll have to round it. It doesn't come out evenly. So we get wx is approximately equal to 9.2 or 9.19. Doesn't say what to round to, so you can use that as your answer. So that's one way. A lot of people don't like using law of sines or law of cosines, those non-right triangle rules. And so there's another way that you could do this problem also. In order to give yourself a right triangle, what you could do is you could use this part of the rectangle. This is a right triangle because it has this right angle here. Let me draw that out. So this would be ZWX. There's the right angle. We know that this is 40 degrees, and we know that this whole diagonal part, the hypotenuse you could call it, is 12. And so you could use a sine or cosine or tangent to figure this out. Since I want to know this side right here, and I have the hypotenuse, and I have 40 degrees, I'll use cosine. I'll say cosine of 40 degrees equals wx, that's the adjacent, over the hypotenuse, 12. And then we'll multiply both sides by 12. And so you would type into your calculator 12 times cosine of 40. And you get 9.19. Of course, you get the same answer. There's just two different ways of doing this. So approximately 9.19. Okay, on to the third page. Here we have another diagram set up, and this one is all about a square. A square is both a rectangle and a rhombus, so it will have 4 right angles, and all 4 of its sides will be the same. In this case, we don't know what the side lengths are. All we know is that this one part of the diagonal is 5. And since this is a rectangle like the last one, this will also be 5, this will also be 5, this will also be 5. And each of these triangles that are formed in the middle, all 4 of these triangles will be congruent, and they're all 45, 45, 90 triangles. In a rhombus, the diagonals intersect at right angles, so all of these are right angles. Also, the diagonals bisect each angle. So if this whole angle is 90, when it's bisected, you get 45 and 45. So what might be helpful to do is just to solve one of these triangles. I'll just take the upper triangle here, triangle DEH you could call it, and it's a right triangle, and it's a 45, 45, 90 triangle, and I know that this side is 5, and I also know that this side is 5. So, you could do the Pythagorean theorem to figure this out. 5 squared plus 5 squared equals DE squared. And you could figure it out that way. You could also remember the really convenient shortcut we had from Chapter 7, first semester, that said in a 45, 45, 90, if you know one of the legs of the triangle, just multiply it by radical 2. So DE would be 5 radical 2. That's a really short way of doing it. I mean, that's the same answer you would get if you kept doing the Pythagorean theorem here, because you'd get 25 and 25, and add those together, you get 50. And then you'd take the square root of both sides. And so square root of 50, that actually can split into 25 and 2, which is 5 radical 2. Same answer, but if you know your rules about a 45, 45, 90 triangle, that'll be easier. All right, I haven't even answered the questions yet. I usually like to investigate and then look at the questions. So let's look at this. Angle GHF. GHF, where's that? GHF, that's 90 degrees. All right, the next one, angle DGH. DGH. So that would be this angle right here, and we talked about how that is bisected of 90 degrees, so 45 degrees. Okay. Number 28, HF. H to F. From H to F. Okay, we already figured out that was 5. And DE. D to E. Okay, that was the one that we did all the work to figure out. That is 5 radical 2. That would be the exact answer, and that's what it says to do. Express your answer in simplified radical form. I think the answer key in the study guide actually says 7.07. That would be the approximate answer. So I suppose you could have either one, but the directions here do say simplified radical form. Okay. Next, we're talking about trapezoids. And you can see in number 30 that what we have drawn in is the mid-segment of the trapezoid. The mid-segment is where you connect each midpoint of the legs. So this is splitting this leg in half, this is splitting this leg in half. And we said that the length of the mid-segment is the average length of the bases. In other words, you add both bases together, 16 plus 4x, and you would divide it by 2. You're averaging. You're adding them up and dividing by 2. And actually, we know the answer. It's going to equal 12 in this case, so we just have to solve this. I would start by timesing both sides by 2. So then you'd have 16 plus 4x equals 24. And so then you can subtract 16 from both sides. And so you get 4x equals 8, and therefore x equals 2. So in this case, x equals 2. Okay, here's another one. Same kind of thing. We have a mid-segment, so we can add together the bases, 10 plus 44, and divide them by 2, and that will equal the mid-segment, 2x minus 1. You know, what you can do, I know a lot of people like to times both sides by 2 right away, and you can do that, but in this case it might actually be easier to just simplify. I can actually add together the 10 and the 44, and you get 54. And I can actually divide that by 2, and you get 27, so I would do that. I'll add 1 to both sides, and we get 28. And then divide by 2, and so in this case, x equals 14. Okay, number 32, another one where we have a trapezoid and a mid-segment. So the two bases, 43 and 4x, those will add together, divide by 2, and that will equal 32. I would times both sides by 2 in this case. So on the right side you'll have 64, and on the left you'll still have 43 plus 4x. Subtract 43 from each side. and we'll have 4x equals 21, and then divide by 4. And you can tell this one doesn't come out evenly. That's okay. Sometimes you get a decimal or a fraction. So x equals 5.25, or 5 1/4. We're not rounding here. That is the exact answer of what it equals. Okay. Next one, number 33, another mid-segment one with trapezoids. So we'll take the bases 2x and 8x plus 3.2, and we'll divide those by 2, and we'll set that equal to 17.1. Alright, so go ahead and times both sides by 2. So on the right, you'll get 34.2. On the left, we can actually add the 2x and the 8x together to get 10x. And so then we'll subtract 3.2 from each side. And we'll have 10x equals 31. Divide by 10, and we get 3.1. Again, not rounding. That is just exactly what it works out to. Alright, and the last shape that we dealt with is kites. And in a kite, you can see it looks like the kite you fly in the sky. It has two congruent sides that are right next to each other, and another two congruent sides that are right next to each other. In a kite, one pair of angles is congruent, and it's always the pair of angles that are between the two different sides. So in this case, angle K is 88 degrees. All right, number 35. You can see here M and K are the ones that are congruent with each other. So I'll have to use the fact that there are 360 total degrees in any quadrilateral, and we'll minus the 60 and the 50, and whatever we get, we'll divide that by 2. So if you type in 360 minus 60 minus 50, you get 250. And then we're going to divide that by 2 because these two angles are congruent. Together they equal 250, but what is just one of them? What's just angle K? 125 degrees. All right. Now on to what I would call the main event. This is where we wrap it all up, where we graph the shape and we tell whether it's a parallelogram or a rectangle or a rhombus or a square or a trapezoid or an isosceles trapezoid or a kite. So first thing is just to graph it. Make sure you graph it correctly. Okay, so I have all my letters plotted. When you connect the dots, make sure you go in order. This quadrilateral is P, Q, R, S. So I'm going to connect them in that order. P to Q, Q to R, R to S, and then S back to the beginning of P. Now, you might be able to tell what it is just from looking at it. That's fine. Like, I think this is a kite. Let's figure out for sure. And the way to figure out is to count the slope. So from Q to R, that's the first one I'll do, I can tell I'm going up 1, 2, 3, and over 1, 2, 3, 4, 5. So this has a slope of 3/5. From S to R, I'm going up 1, 2, 3, 4, 5, and over 1, 2, 3. Those are reciprocals of each other. They're not parallel, they're not perpendicular, they do intersect. And so what that tells me, even though they're not parallel or perpendicular, because they have the exact same slope numbers, QR is going to be congruent to SR. And I'll just write a little reason, because they have the same slope numbers. They don't have the same slopes. They don't have the same slopes. They just have the same slope numbers. I can actually just count that from Q to P is 2, and from P to S is 2. Since they aren't at a slant, they're just straight vertical and straight horizontal, you can easily count the distance. So QP is going to be equal to PS. All right, so I have two sets of consecutive congruent sides, and that is what you would need to write out to say it's a kite. So You can go ahead and write down kite, but then you kind of got to restate what a kite is. Two sets of consecutive congruent sides. And probably a little easier for you to write this. I'm writing on the iPad and it's not always easy. Okay, so you don't have to have a huge long explanation, but you should annotate your diagram so I can figure out how you know, and you should write down any facts that support your final answer. Alright, let's do the next one. So I'll go ahead and plot all of these. Okay, so make sure you label them with their letters, P, Q, R, S, and that's the order we're going to connect this in. So P to Q to R to S, and then the S, the last letter, connects back to the first letter. Alright, I think it looks like a trapezoid. Here's one way that we can tell. A trapezoid has one pair of parallel sides, exactly one pair. And from the looks of it, it's SR and PQ. And I don't know if you really need to count the slopes there. I think we can say that SR is parallel to PQ because both have slope equal to 0. They're both horizontal lines, which is the same slope of 0. So this is a trapezoid. Maybe it's an isosceles trapezoid, we'll see, but I'm going to start off by saying it's a trapezoid because it has one pair of parallel sides. So again, you kind of got to restate the definition of the shape you're saying. Alright, so it's either a trapezoid, or we could go further and say it's an isosceles trapezoid. Alright, so how do I know if it's an isosceles triangle? There's a couple of different ways you can find that out. Probably the main way is, are the legs from P to S and R to Q, are those congruent? That would make it isosceles, where two sides are the same. Another way that you could figure out is, are either of the base angles congruent? Like, is P congruent to Q, or is S congruent to R? That might be a little more difficult to figure out since we don't know any of the angles. So I'm going to go ahead and count the slopes from P to S and R to Q. So from P to S, I'm going up 1, 2, 3, 4, 5, 6, 7, and over 1. So that has a slope of 7 over 1. And going from R to Q, I'm going down 1, 2, 3, 4, 5, 6, 7, and over 1. So that has a slope of negative 7 over 1. Those are not the same slope, and they're not opposite reciprocals. They're not parallel, they're not perpendicular, but they have the same numbers. So I'm going to say that PS is congruent to RQ because they have the same slope numbers. They're not the same slope, but the same slope numbers. And what we're getting at here is, if you made this into a right triangle and you made this one into a right triangle, their hypotenuses, which is what we're figuring out, would be congruent. So, therefore, this is an isosceles triangle. So we'll say isosceles, I'm sorry, not triangle, isosceles trapezoid is what I meant to say. It is an isosceles trapezoid. That'll be our final answer. Can't get more specific than that because the two legs are congruent. Okay, on to number 38. I'll go ahead and plot these. Okay, now I got them plotted and labeled. Make sure to connect the dots in order. So P to Q, Q to R, R to S, and then go back from S to the beginning of P. Okay, kind of looks like a rectangle. I guess we'll see. Pretty much what you always want to do once you graph shape is count the slope. Just a word about counting the slope. You always want to count the slope from left to right. So if I wanted to know the slope of this line here, you don't want to count from R to S and go backwards. Slope is rise over run. So you're going to do how much is going up or down, and then I'm always going to count how much it's going to the right. So I'm going to go S to R, and from S to R it's going up 1 over 1, 2, 3, 4. So 1/4. Remember also, as just a double check, if the line is going up from left to right, it should have a positive slope. Now I would bet that PQ has the same slope. Let's count that. Up 1 over 1, 2, 3, 4. Yep. So those sides are parallel. Maybe I'll write that down. SR is parallel to PQ because they have the same slope of 1/4. Okay, let's take a look at the other sides. So if I'm going to count the slope of this line, first of all, know right away that this will be negative. It's going down from left to right. So I'm going down 1, 2, 3, 4, 5, 6 and over 1. So that has a slope of negative 6 over 1. I'm going to bet the other one is the same. Let's count it. Down 1, 2, 3, 4, 5, 6 and over 1. Yep. So we'll also say that PS and QR are parallel. And they have the same slope of negative 6. Negative 6 over 1. Okay, so this is definitely a parallelogram to start with, at least. And the reason why I know it's a parallelogram is because opposite sides are parallel. That's the very definition of a parallelogram. That's the very definition of a parallelogram. Opposite sides are parallel and congruent, really. Either reason you could say. But I've been going with parallel, so that's what I'll stick with. All right, now it kind of looks like a rectangle. I really like this problem because even though it really looks like a rectangle, in order to make it a rectangle, to figure out that it's a rectangle, it would have to have 4 right angles. And we don't know what the angles are. So some of you might have said it's a rectangle, and now you know, well, we can't say it's a rectangle. Some of you might say, well, I can't prove it's a rectangle, we just don't have enough information. But actually, neither of those are right. We can actually prove this is not a rectangle, because if you compare the slopes, if this were a 90-degree angle, these slopes should be opposite reciprocal. Now they are opposite, because one's negative, one's positive, but these are not reciprocals. So we know for sure this is not a 90-degree angle, this is not a rectangle. So parallelogram is as specific as we're going to be able to get. You don't really have to explain why it's not something. You don't have to explain why it's not a rectangle, although you could if you wanted. But we'll just stick with parallelogram. Okay, on to the next one. I'll go ahead and plot these. All right, there are the points. Make sure you got them correct. And we'll connect these in order. P to Q, Q to R, R to S, and then S back to P. All right, kind of looks like a rectangle, but now we know we got to watch out and see. So let's count the slopes. I'm going to start from P to S. So I'm going down 1, 2, 3, 4, 5, 6, and over 1, 2, 3. So down 6 over 3. Now you can reduce that. If you reduce that, it actually reduces to just negative 2. That's fine. But make sure you have the original slope there, because we might need to use that. I'm going to go across. I'm going to guess that this is also negative 6 over 3. Let's just count that. Going down 1, 2, 3, 4, 5, 6, and over 3. So I'm going to write the same thing. Negative 6 over 3, which equals negative 2. So it's like you have the unsimplified slope, the original slope numbers, and then you have the simplified reduced slope. Let's count from P to Q. We're going up 2 over 1, 2, 3, 4. So 2 over 4, or if you reduce that, it equals 1/2. And if you count from S to R, it is the same. 2 over 4, or 1/2. Okay, so I'm going to kind of start off the same way. I'm going to say, first of all, this is a parallelogram because opposite sides are parallel. They have the same slopes, and you can see I've marked it above. All right, so can we get more specific? I said it kind of looks like a rectangle. Well, in order for this to be a rectangle, we would have to have 4 right angles. And the way to figure out if it's a right angle is to see if you have opposite reciprocal slopes. And so you would compare negative 2 and positive 1/2. And yes, -2 and +1/2 are opposite reciprocal slopes. And since it's those two slopes everywhere in this rectangle, -2, 1/2, -2, 1/2, all four angles are going to be right angles. So all four angles are right. And that makes this a rectangle. If you wanted to see if it were a square, for a square all four sides would have to be the same too, and it is not a square because it would have to have the exact same slope numbers, and this does not. Okay, so rectangle. Okay, here we have some more, but we're not graphing these ones. They are already displayed with the data that they're giving us, and we just have to make the decision. So give the most specific name for the quadrilateral and explain. Okay. Well, when I start off, I think it's a trapezoid because I have one set of parallel sides. And let's see here, the angles are not bisected. So, you know, if you were thinking, well, it has one pair of parallel sides, maybe the others are too, and it could be a parallelogram. If it were a parallelogram, the diagonals would be bisected, and these are not. So I'm going to go ahead and start by saying this is a trapezoid because it has one pair of parallel sides. Again, feel free to abbreviate your explanations like I'm doing here. You don't have to write in complete sentences. It's okay. And even if we add the diagonals up, they're not equal. So it's not going to be an isosceles trapezoid either. So just a trapezoid. All right, number 41. Okay, looks like we have one diagonal that's bisected. Maybe the other one is, maybe it's not, I don't know. We have one pair of opposite sides congruent, but I don't know about the other one. Like I know this is 9, I don't know if this is 9. So there's kind of a bunch of information that doesn't really add up to anything. So this does not meet any of our rules for any of the shapes that we studied. We can still give it a name though. This would just be called a quadrilateral. It's still a four-sided polygon. So it's a quadrilateral, and you could write, there's not enough information to say it's any one of the shapes we studied. Okay, and the last one. Looks like I have four sides congruent. You might be very tempted to say that that is a square, but actually, four sides congruent is the definition of a rhombus. Four congruent sides. Now, how could you prove it's a square, or how could you explain that it's a square also? For it to be a square, it would have to have four sides congruent and four right angles. And we don't know if it has four right angles. You might say, well, wouldn't it have to, otherwise it couldn't look like this? No, absolutely not. You could have a shape that looks, I'll try to draw this well. You could have a shape that looks like this, where all four of these are the same, but they're not at 90-degree angles. It's not a square. So just a short, simple explanation there. It's a rhombus. All four sides are congruent. All right, good luck studying.